All right, so before we ended our first session, I asked you to identify the types of intermolecular forces existing in sulfur dioxide. But of course, before you do that, you should be familiar with the structure. I believe during your junior high years, they already taught you how to draw Lewis structure. So I hope we don't have problems with that. So this is the structure of your sulfur dioxide. There you go. So during the first part of our lecture, I've mentioned that when the element is situated at the far right side of the periodic table, what is the charge? It is negative. When the element is situated at the far left side, ano yung ating charge? It is positive. So in this case, si oxygen ay what? Oxygen is partial negative, sulfur is partial positive, and this is partial negative. Now, I also mentioned na ang direction ng arrow is from the positive going to the negative and the positive going to the negative. So, why are we doing this? Kasi nga, ano ang first step natin para makapag-identify tayo ng types of IMF? Identify first whether there is a net dipole, di ba? Identify first if there is a net dipole. So, if there is a net dipole, automatic, yun ay polar. Kung wala siyang net dipole, ito ay non-polar. Okay, I hope you can still recall that. Please don't forget that, no? So, in this case, since the arrows are going in opposite directions, isipin mo ay magka-cancel ito. Magka-cancel ito. So, pag nag-cancel yan, walang net dipole. So, ito dapat ay non-polar. However, that is not the case, no? Bakit? So, when we identify whether molecules are polar or non-polar, we also take into consideration the symmetry, no? So, the technique is, hatiin mo siya sa gitna. Ayan, hatiin natin to sa gitna. Ngayon, hinati ko siya sa gitna. Pantay ba? Hindi. Kasi dito, single bond lang. Ito ay double bond. So, kapag hinati mo sa gitna at hindi pantay, automatic ito ay polar. Unsymmetrical, automatic, polar. So, this is a polar molecule. So, now, alam mo na kung polar or non-polar yung molecule and we have ruled out na polar nga yung ating molecule. What are the types of intermolecular forces existing in sulfur dioxide? Okay, so una, syempre, meron siyang London dispersion forces kasi lahat naman ng molecules may London dispersion forces. At kapag polar yung molecule, automatic, meron kang dipole forces. Ayan. May hydrogen bonding ba tayo? Wala po. Kasi saan nga lang po nag-o-occur ang hydrogen bonding? Kapag may OH, may NH, at may FH. Ito ay SO. So, wala tayong hydrogen bonding. So, actually, it's another technique, no, to identify polarity. Hatiin nyo sa gitna. Say, for example, here, yung ating methane, CH4, o hatiin natin yan sa gitna. O pag hinati mo sa gitna, pantay ba? Pantay siya, di ba? Pag pantay, symmetrical, automatic ito ay non-polar. So, tama, no? CH4 is non-polar. O, try natin hatiin yung hydrogen fluoride. Okay. Kapag hinati natin to sa gitna, pantay ba? Hindi. Sa kabila ay hydrogen, sa kabila ay fluorine. So, kapag unsymmetrical, automatic, ito ay polar. So, that is another technique you can do, no, to identify polarity. Okay, let's move on to the next topic. Properties of liquids. So let us look into the effect of intermolecular forces on liquids. The strength of intermolecular forces of attractions due to dispersion forces, dipole forces, and hydrogen bonding affect the physical properties of liquids. So madaling sabi, yung ating intermolecular forces na-affect niya yung properties ng liquids. Ano ba yung mga properties ng ating liquids? We have surface tension, viscosity, vapor pressure, boiling point, and molar heat of vaporization. So, whether strong ang intermolecular forces or weak ang intermolecular forces, it will determine kung gaano ba taas din ang ating boiling point. Kung gaano ba ka-viscous, is it viscous or less viscous ang ating liquid? So, we'll delve deeper into each property later, no? Let's start with surface tension. So, surface tension is the amount of energy required to stretch or increase the surface area of the liquid. So, the key word here is energy to stretch. This is the energy you need to increase the surface area of your liquid. So, the surface tension of liquids varies greatly based on the nature and strength of the intermolecular forces. So, whether strong ang surface tension, mas mataas ba yung energy na kailangan mo or lower, it would depend kung ano ba yung existing intermolecular force dun sa iyong liquid. And what is the strongest type of intermolecular force? It is your hydrogen bonding. So, molecules with high IMF also have high surface tension. So, let's write here properties of liquids. So, under surface tension, if the intermolecular forces are high or strong, the surface tension is also high. So, directly proportional yung kanilang relationship. So, it's good that you actually make a summary like this para hindi kayo nalilito during exam. So, if you're going to look at this one, this illustrates how surface tension works, no? So, if you're going to look at here, there are different forces balancing the liquid molecules, no? On top of the surface, yung forces ay from left to right, no? Naghahaltakan sila. Tapos dito, may tumutulak pataas, may tumutulak pababa. Kaya nga, when you pour water into your glass, hindi naman siya basta-basta nagsispill, di ba? Pag malapit na siyang mapuno, parang dumidikit yung tubig doon sa surface. This is because yung mga forces na nag-act upon dun sa water, yun nga, merong humihila from here to there, tapos may tumutulak pataas. Kaya nga, para siyang naka-concave, no? Ganyan yung itsura, para siyang nakapalobong ganyan. So, surface of any liquid behaves as though it is covered by a stretched membrane. Okay? So, these are examples of your surface tension. Let's move into this one. Forces of attraction in liquids, cohesive forces, and adhesive forces. So, dalawa yung forces ng attraction sa liquids, no? Either cohesive or adhesive. Pag cohesive, ayan, pag sinabi nating cohesive, this is what? Between like molecules. Like molecules. Parehas na molecules. Kapag adhesive, this is from different molecules, no? Different molecules. So, what is the example to that? So, if you're going to look at here, yung tubig mo na nasa test tube, pag tinapon mo yung tubig, di ba, anong nangyayari? Meron pa ring naiiwan minsan sa loob dito ng test tube. That is adhesive force, no? Yung water molecules mo, dumikit doon sa glass molecule ng test tube mo. Anong example ng cohesion? I don't know kung nakakita na kayo ng mercury, no? Pero ang molecules ng mercury, gusto nila nagdidikit-dikit sila. So, kapag tinapon mo itong mercury na ito sa test tube na ito, walang matitira dito. Walang matitira sa test tube. Kasi, yung molecules, kung saan pupunta yung isa, doon din, sama-sama silang pupunta kung saan pupunta yung isang molecule. Nagdidikit-dikit talaga sila. So, that is cohesion. So, the reason behind there is that the mercury molecules, no, gustong-gusto nilang nagdidikit sa isa't isa. Ayan. Next, capillary action. So, capillary action can be defined as the ascension of liquids through slim tube. So, capillary action, parang yung sa straw ninyo, no? Kapag umiinom kayo ng juice, pagkatusok ninyo ng straw ninyo, umaakyat yung liquid, no? So, that is capillary, no? This is the rise, no? Yung pag-akyat ng liquid sa maliliit na butas, no? Into narrow tubes. Now, let's talk about viscosity. So, viscosity refers to a liquid's resistance to flow. So, basically, tayo mga Pilipino, may term tayo dito, di ba? Yung malabnaw at yung malapot. So, pag sinabi mong viscous, mahirap mag-flow yung tubig, no? Viscosity of liquids increase with increasing strength of intermolecular forces. So, viscosity ng ating liquids, mas mataas yung intermolecular force ng ating molecules, mas mataas din yung viscosity nila. Ibig sabihin, mas hindi sila nagfo-flow. They are more viscous. Strong intermolecular attractive forces make it more difficult for molecules to move with respect to one another, no? So, hindi basta-basta nakakapag-slide yung ating liquid molecules with each other kasi nga, strong yung ating intermolecular force, no? Mas strong yung ating bonding. Okay, so these are just the values for viscosity for different liquids. Okay, so on our next session, we will be discussing about molar heat of vaporization and boiling point. If you have any questions regarding this lecture, don't forget to post it on our discussion forum.